Hey, Sumant.
Hi.
So we have Advik who's going to join us. I
Okay.
think Tanuj is already there and I think Pranav is coming in. Hey, Pranav. Good morning.
Good morning.
Morning. Hey, Advik.
Sir.
Hey, welcome. Is Tanuj around?
Yes, sir. I'm here.
Hey, hi. Welcome.
We should wait for a couple of minutes.
Yeah. Just admitting them. Since it's Zoom, we're using this admit procedure so that there's no concerns. Okay. So I've got, is Neha around? Yeah, Neha is there. Hi, Neha. Good morning. Hi, Pranav. Sudhit, Tanuj, Madhav, Yashwant, all of them are there. Madhav. Okay, looks like fine. Great. Hi, Yashwant.
Well,
Hey. Morning, all of you. Thanks a lot for coming in on time. Over to you, Sumant.
Good morning, all. So, how many of you have worked out the example that I had shared earlier?
Sir, I did.
Okay, so you got the answer?
Yeah.
Fine. And anybody else faced any difficulty with the problem that was shared? I have asked you guys to solve uh, two two problems. The first one was binary conversion for the number 100, and the other one is the number 1000. If you have solved it, then good. You can mail me the solution. I will have a look into it. And for the others who are facing any difficulties, please reach out to me. I will help you in solving that, because uh, this particular thing forms a base for your programming. Uh, the entire uh, programming concept, or once you write a piece of code, it gets converted into ones and zeros. That's the end product. So you need to understand uh, how your once you have written code, how will it get converted, and how will the machine understand it. So let's let's start our today's session. Let me share my screen.
could you put your email on the Hangouts chat?
Yeah, sure, sure. Okay, I guess you are able to see my screen.
And is there a way you could share this presentation with us?
Yes, sure. I'll share all the presentations with you. Um, After the end of the class, just remind me. I will share this uh, presentation over email. Okay, so let's get started for the day. Today we will be learning about uh, a few more topics on programming before you jump into programming. Like you need to know a few other basics of programming, and then we'll be moving on to the uh, we will be moving on how we can use Python, and then the required tools that you will be using to code Python. Uh, so let's get started. Um, okay, so before we actually start coding and write a program, let's see how a basic program works. See, a computer CPU can only understand instructions that are written in machine language. Now, we have discussed the term machine language in our previous lecture. So, um, machine language is nothing but a language that a CPU understands or a computer understands, and the the machine language in a way, if you can open it and if you can read it, it's nothing but a series or sequence of ones and zeros, which will make sense to the machine. But once you read them out, it might not make sense to you, but it does make some sense to the machine because machine understands binary. But whereas it is a bit difficult for us to understand the binary. So because people find it difficult to write the entire uh, instruction in machine language, like you cannot write a series of ones and zeros and call it a program, because once you write it and you refer to the same program after a week or so, you will have a tough time uh, uh, on the same on understanding the same program that you had written. Say let's consider this example. See, say that I give you a sequence of 100 numbers to by heart. Now you might be by hearting them today, and you might be uh, telling the sequence to me tomorrow. But what if I ask you the same sequence after a period of time? Everybody might forget it. I don't think we have that strong memory power that would help a regular human being to remember the entire sequence in a correct way. We might go wrong uh, at any point of time, and we might not actually understand what that sequence means, because after all it's just ones and zeros. So what people have come up with is, for a sequence of ones and zeros, uh, they have mapped it to a specific instruction. Now tell me, what do you understand by the term instruction? Like just the English term instruction. Do you have a, do you I would like any volunteers to uh, help me with this thing. What do you understand by the term instruction?
Instruction is like a set of commands.
Uh, yeah, like say, can you tell me any instruction that say you would suppose say you have a pet, you have a dog at home, and you give it an instruction that do not venture outside the premises of the home. So that's one kind of instruction. Your parents might be giving you a set of instructions like uh, do not talk to strangers. That's one common instruction that parents might be giving us when we are young, and we have other types of instructions that we might be giving. Suppose say I can give an instruction to my washing machine uh, stating that wash my clothes for a certain amount of time and then dry the clothes uh, in a certain pattern. So that forms an instruction, and instruction um, is it is very easy when we tend to give it in our in a language that we understand. So see, I can understand instructions given in English or any native Indian language, because we are accustomed to such kind of uh, the rules of the languages. So it's easier for us to understand instructions in a language that I speak. But what is the language that computer understands? It's machine language, and machine language is again series of ones and zeros. So what we can do is, in order to give an instruction to a machine, what we can do is we can map a series of ones and zeros to an English word and call it an instruction. For example, say I want to add two numbers. Say I want to add 10 and 20. So I form an instruction called as add, and this add instruction has a sequence of ones and zeros, and I map this ones and zeros to the instruction add, and that's how I can write some piece of code that my machine would understand. Okay, so machine language instructions exist, but yeah, it might not be feasible for us to use the machine language instructions. So uh, we go a level up, and we call that as the assembly language. I'll be giving you a series of um, hierarchy over here on how the entire program would work. So uh, assembly language is nothing but the instruction that we have mapped to say, suppose say I want to add two numbers or subtract two numbers. So I frame a keyword called as add, sub, mul, like multiply, etc., and I call that as an instruction. And this instruction written in simple English could be understandable by both me, the end user, as well as the computer. Okay, so let's see on how a program actually works. So uh, a program actually works in three phases: fetch, decode, and then execute. Now, what do we mean by fetch? Say, uh, I have a dog and I throw a stick. So what does the dog do? It fetches the stick for me. So in a similar way, I have a program and it resides on the hard disk. Now we had seen in our earlier classes that how we can store a program. A program is stored inside the hard disk. So what we need to do first is fetch the program, like fetch the program from the hard disk. Okay, and then we need to decode the program. Decode in the sense, say I have written my program. Now what does my program consist of? Series of instructions, right? So I have fetched my program and I have decoded the series of instructions. What's the next thing to do is execute these instructions. That is, say I have a series of instructions like add two numbers, subtract two numbers, multiply two numbers, or divide two numbers. So I have to execute all of them, and then once all these instructions are executed, then I can call that my program has been executed. So let me just repeat it once again. What do I need to do? I need to fetch a program from my hard disk, decode the instructions inside my program, and then proceed to execute it. Okay, so overall, the process of fetch, decode, and execute cycle uh, is the process of executing a program. Okay, so we have seen. I have just explained all these 3 points to you, but just for the purpose, if you want to give it a read, I will be sharing this deck with you. You can refer them later. So, what have we discussed up to now? We have seen that machine language is hard to understand or hard to read by the humans. So, what we do is we do not code in machine language. We code in different programming languages by mapping the instructions of the machine language to basic English keywords. And then once we write the program, what do we need to do in order to execute it? We need to fetch a program, we need to decode the program, and we need to execute the program. Now, what I'm doing is I'm just talking, and you might not be understanding this concept because you need to uh, have hands-on experience. But once you have the hands-on experience, which you'll be getting in the next 1 or 2 classes, you will, and once you revisit this lecture again, or this presentation again, you will be able to understand uh, by relating it to the execution of program. But for now, just understand that uh, what all we have learned up to now. So machine language. What's a machine language, and why cannot we use machine language directly, and why we need programming languages such as C or Python in order to uh, uh, do it, and then how and uh, how the execution of the program takes place. It takes place with the help of three steps: fetch, decode, and execute. Fine. Let's move on to the uh, next topics. So this is how uh, you can visualize the stuff going on. So you have your main memory over here, and this is your program series of ones and zeros. This series of ones and zeros, which forms your program, is first fetched. The first step, fetch the next instruction in the program. So line by line, you have a series of instructions, and each line is first fetched. Next, I have fetched the first line, say a series of numbers 101, 00, 001. Then what actually happens is the CPU decodes this instruction, because the CPU, which is the computer, it understands what this instruction is. Now, just reading these numbers, you might not understand what this is, but the computer, it understands what this instruction is, and then it decodes this instruction to determine which operation it has to perform, and then finally it executes this instruction. Like the CPU, once it has fetched this instruction, it executes this instruction. Okay, so three phases: fetch, decode, and execute. Fetch, decode, and execute. Now we have seen that um, we have seen what a machine language is. A machine language is something similar to this. So it's a sequence of ones and zeros. Then moving on, um, during the initial days of computer programming, there was something called as assembly language. Okay, so this was the most uh, primitive type of language, which which was used to code the machine language, right? So what an assembly language is actually is, uh, they have decoded the machine language into a series of instructions, and then uh, what they have done is the mapping. But this mapping was very crude. In order to execute one basic step, uh, uh, like what we do in Python, or what we do in C, it took multiple steps. Like suppose, say you wanted to add two numbers, you wanted to add 1 and 2. Now consider it in Python, it could be done in one line, or uh, one step. But in assembly language, it took 4 to 5 steps. It was hard. So what they had done is, uh, the world, they have moved from assembly language to something higher. So first, but before moving to higher languages, let's just understand what an assembly language is, so that we can understand why there was a necessity for having a high level programming language like Python. Okay, so I don't think this is uh, clearly visible, but let me just read out this assembly language program over here. There's an instruction called as mov, move, move, and this is uh, uh, I am moving a number into uh, into uh, into this variable. So what I'm doing is I am storing the number 2 into this thing. You need not understand this assembly language, but I'm just showing you the syntax on of how an assembly language would look like. So what what this is how an assembly language looks like, and in order to add two numbers itself, you had to write a series uh, of instructions and then perform the addition. Okay, so this is your assembly language, and then you have something called as an assembler. Now as an assembler, you can just assume it to be some software. Sorry. So you can assume an assembler to be some software which will decode these instructions into machine understandable language form. So what an assembler actually does is it takes an assembly language program and then converts it into machine language program. Okay, but just understand that assembly language is tough. It is lengthy, and it is a primitive and low level language. Now since we do not expect ourselves uh, to code um, 100 lines of code to perform a simple set of instructions, whereas the same the same level of uh, uh, program can be executed using a reduced a number of lines, as in Python. Suppose say your assembly language would take 100 lines, Python might take 4 to 5 lines. That's how optimized Python will be. Okay, so this is the first type of language that we see here, is called the assembly language. Uh, okay, I have a message from Tanuj, says that saying that he has accidentally left. Give me a minute. I think we have a problem with Tanuj. Okay, so welcome back, Tanuj. Okay, so let us resume our session. Is everybody able to see my screen?
Yeah.
Yep.
Yeah.
Okay. Great.
Yep.
So let's get back to our discussion. We have seen what a machine language is and what an assembly language is. So let's move on to the topic of high level languages. Now, the problem with assembly language is it took a lot of lines to execute a simple program. Like in order to add two numbers, you had to write 4 to 5 lines. In order to um, print something, you had to write 5 lines. But whereas a high level language like Python, you can do it with reduced number of instructions. So let's see. Uh, let's try to explore these high level languages. Python is one of the high level languages that we will be discussing in this lecture, and we will be using Python in the rest of our course in order to execute programs for IoT. Okay, so let us start our uh, first instruction of Python it is called as the print statement. So what does this print statement does over here is it will print anything that you put in the braces. It will print anything that you put in the braces onto your computer screen. Now this is a basic and one of the most useful instructions in Python, because you will have to print your answers of whatever you do. Like suppose say you have added two numbers and you need to uh, tell or output that addition, and how you actually do is with this statement print. Now have you all installed uh, Python in your computers?
Yeah.
Yeah.
Okay. So what have you installed? Uh, Idle or Anaconda?
I have both. I have
I have idle.
Yep. Okay.
I
Okay.
have
So
idle as well.
yeah, done. So let's see. Can you please open up Idle? It is loading at my end. You should be seeing something similar to this over here.
I have 3.72 shell. Does that have a difference?
No, there's no difference. Like there is a minor difference, but anything about version 3 will do. Okay, have you all opened it?
Yeah. Yes.
Okay, so
Yeah.
let's start uh, our course on Python with the first instruction called as print. Okay, so print hello world. Now, there is something that you need to follow. Immediately after the keyword print, you will have to start uh, a, a braces, and then you need to give quotes if you want to type paragraphs, or if you want to type a sentence, and then end your sentence uh, with another quote, and then you need to complete this print statement with another braces. Okay, and then once you hit enter, it will print whatever is written inside the quotes. Okay, so why don't you guys try to execute this one line and see and let me know if everything is fine at your side, or if you are facing any issues.
Yeah, and I tried it. Yeah, it's working. Done.
Okay.
Yeah. Yeah.
Yeah, everything's good with me too.
Okay. Fine. That's a very basic thing. So that's your first print statement. So what you can do is, uh, if you want to uh, edit or re-execute this instruction over again, what you can do is you can go to the instruction again by using your arrow keys and try to hit enter again. So it will give you the instruction again. Now let us try to print numbers. See, with this thing works without quotes as well. I can do this as well. Print 3. I can put it in quotes as well. Okay, but there is a difference between this 3 and that and this 3. I will let you know about the difference in our next class, but just remember that once you change the syntax of these statements, then the behavior might change. Okay, so that's your first step of Python. Let's move on uh, with our discussion. So, uh, but we have seen that in order to print something or output something on our screen, we just executed one instruction. I've just said print this, and that thing got printed. But whereas if it is this case of an assembly language, let us see how many instructions we have to give for outputting the scene on our computer screens. Now say I want to output a character called as A in my assembly language, then I will have to write 3 lines of code. First, I'll have to move the character to some place. Then I will have to call, I'll have to let my machine know that this, whatever I'm trying to do, it should be outputted on the screen. And then I'll have to call some interrupt so that the whatever the output is, it has to be displayed upon my monitor. Now see, we have reduced 3 instructions to one single instruction. And let's see the beauty on uh, and another type of beauty. Now, if I give you these three instructions, can you would you have guessed what uh, this might be doing without me telling you that, hey, this outputs the character A upon your screen? But just by reading the instructions, were you able to guess what it was doing?
No.
No. So that's the beauty of high level languages. All the instructions that you write in high level languages are instructions of the instructions are framed in basic English that we all use in our daily usage. See, print is something we are pretty familiar to, and we understand what that instruction means. You need not be a programming geek, or you need not know uh, any programming language in order to understand what this instruction might do. Print this thing. So it just printed. So that's the beauty behind using a high level language. Okay, have you got this difference on why we are preferring high level languages as compared to assembly? Yeah, is that an yes or no? Have you understood this concept?
Yes.
Okay, so in assembly we had to execute or we had to write three different lines. In Python we had only one line to write. So that's why uh, we would like to prefer high level languages. Let's move on to the concept of compilers and interpreters. This is a basic step that you will have to understand before we jump into programming, or we write Python code. Once you understand this basic difference, it'll be easier coming forward to handle any programming language, or understand how that particular programming language would work. Now you have something called as compilers and interpreters. We had already seen the concept of an assembler. Now what an assembler did is it translated the assembly language into machine code. See, we had seen here that this assembly language program was uh, was translated by the assembler into um, a machine understandable language. Similarly, a compiler and an interpreter also uh, does the similar job, but these are for high level languages. Okay, and uh, there is some difference between a compiler and an interpreter as well. Both of them are for high level languages, but there is some difference between both of them. Now let us try to understand the difference between a compiler and an interpreter. Okay, so what a compiler does is it takes a few lines of code, then um, what it does is it converts the entire instructions inside it to a machine understandable language format, and it just gives you the that compiled output, so that you can execute it as per your wish. But whereas an interpreter, what it does is uh, it can it converts uh, or it executes the instructions line by line, so that you can execute uh, uh, your lines of code, uh, if even though if you have some error or some bug inside your code. Now you might not understand it this way, but let me just show it to you practically by taking the example of a simple C program. Now it's okay that if you do not understand uh, a C program or a Python program for now, but I will just demonstrate you the flow, so that you will be able to understand the basic difference between a compiler and a interpreter. Okay, fine. So this what you see here is a C program for printing the output hello world upon my computer screen. Okay, so what my compiler does is, like compiler and interpreter or your assembler, they are nothing but some sort of softwares. Okay, just understand that they are softwares, but the but how they let you execute your code varies. Okay, so let me just try to execute the C program. Now, now I have written my uh, C program, and what I can do is, first I need to compile my program using a compiler. So I have a compiler called as GCC, and I have my input file called as ex.c, and I have an output called as ex.out. Okay, so once I do this, I get an ex.out file for me, that is the compiled version of it, and then this is how I execute. Okay, so once I had executed it, you could see that it has printed, sorry, it has printed the keyword hello world upon my output screen. But whereas in my Python program, I have written the instruction, I hit an enter, I get an output. Okay, so once again, for using a compiler, what you need to do is you need to write a program, you need to compile that program, and you need to execute that program. So what are the steps over here for using a compiler? Write the program, I have written the program, then compile my program. This is the instruction that I need to give for compiling my program, and then getting a executable out of it. Then once I have got an executable, I have to execute my program. See, I have to do 3 steps in my compiler. But whereas in an interpreter, you can directly write your code, and you can uh, you can execute it on the fly. Okay, so I hope you have got or understood the difference between an assembler, a compiler, and an interpreter. Any doubts? or would you want me to repeat the concept of an interpreter and a compiler under ASM? It's okay that if you do not understand at this point of time, but moving forward, you will be using Python, and you will be able to understand uh, what is the concept of an interpreter. But just know the basic difference. In a compiler, you'll have to first compile your code, and then you'll have to execute it. But whereas in an interpreter, you can execute your lines of code one by one without actually uh, turning your entire code into machine language, machine understandable code. Fine. Let's move on. What I've done is I have written my C program, and I have just executed this thing, and then I have also practically shown you that uh, what we can do in an interpreter is we can execute our lines of code without actually converting them directly into machine language code. Like we did not uh, convert the entire code into machine language code uh, uh, immediately. We can do it step by step, or execute it step by step. But what is the main uh, uh, main advantage that an interpreter can give uh, from a compiler, apart from reducing the number of steps, is even though uh, uh, you you make some mistakes in your code will get executed and up a line above your mistake. Suppose say you have 100 lines of code, and you have made mistake at your 99th line. In C, or any language that uses a compiler, what actually happens is it doesn't let you execute your first 99 lines of code. It simply doesn't allow you to do that. But whereas in an interpreter, you can execute the first 99 lines of code, and say you have an error at the 100th line, it will point out that um, there's an error at your 100th line. Please correct that error, and you might want to try the execution once more. So that's the basic difference and advantage of having an interpreter. Okay, so we have done this step. We have downloaded and installed Python. Now let us we have completed the entire theory of um, the various programming languages, and what is the basic difference between a low level language and a high level language, and what are the advantages that a high level language that like Python has to offer us. Now from this moment onwards, let us try to concentrate on uh, using the high level language of Python, and let's 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 see on how we can use Python to code our stuff. So to begin with, you will have to know a few things associated with Python, and those are called as keywords, operators, and the syntax. Now, keywords, in the sense, there are some reserved instructions in Python which you can call directly and perform the operation. And then there are a few operators, operators in the sense addition, subtraction, multiplication, division, and a few other basic operators, and the syntax associated with it. Syntax in the sense how you format these instructions. So let us start with our Python keywords. We have a set of 1, 2, 3, 4, 5, 6, 7, 7, 4, 8, 34 keywords in Python, and let us see. Let us uh, have a look at them, and we'll try to execute uh, some of them for now, and see what they can offer us. Okay, so the main keywords are and, as, assert, break, class, continue, def as in define, or you can define a few things, del as in delete, elif, else if, else, except, false, finally, for, from, global, if, import, and a few others. Yeah, you might be facing difficulties in understanding why we have to learn these keywords, but once you jump into programming and you keep on using these keywords, it will be easy for you to know or know the purpose of these keywords. Okay, so we have seen the keywords, and there are a few operators as well, like the addition operator, the subtraction operator, uh, and uh, uh, stuff like that. So let us try to perform or and use the keywords. Say I want to add two numbers. Say I want to add two numbers, 100 and 1000. I can directly perform it with the addition operation over here. See, I want to subtract two numbers. I want to subtract 100 from 1000. I can what I'm expecting is a negative number, negative 900 minus 900. See how easy it is to add or subtract two numbers in a high level language. In an assembly language, for the same instruction, you might have to waste uh, 3 lines of code, 4 lines of code, something which you do not understand at after a few after a few uh, after a few weeks of you writing the code. But here, um, it is just basic English instructions or mathematical instructions that we are giving over here. Okay, so we have added and subtracted integer values over here. We can do the same for fractions as well. Say 100.23 minus 100. See, this is giving me the answer 0.23. I can perform 45 by 39. So I am able to perform basic mathematical instructions over here, and it is pretty easy for me to perform operations in such a way. I can do this one as well. What I can do is I can print 45 by 89, and I can get an answer in this way as well. Now you might be confused on why I have used the print statement when I am directly getting the output only. We cannot because we cannot keep on typing our entire commands in this way and uh, seeing the output at once. What people actually do is they code multiple lines of code and then try to execute these multiple lines of code uh, at a time. So for this, you have an option called as file, new file, and it will open up a new file for you. Can you try to open up a new file in this way? Go to file and new file. It will open a blank untitled file for you. And here I can write my instructions as well. But once I hit an enter, nothing happens because this is another type of execution where I do not want my different lines of code to be executed one by one as I enter, but uh, they should be executed once I instruct them to. You can also perform addition. I can perform division and multiplication. In order to perform multiplication, you need to use the symbol star. And in order to run your program, you have an option called as run and run module. It will ask you to save at any location. I will save it with any name and it will execute whatever lines of code that I have written. Now you can see that it just printed hello world and not the other instructions. So in this type of module, you can only visualize your output with a print statement. In your actual interpreter mode, uh, as soon as you type, you will get an out. But if you are typing it in a file, in a Python file, you will not get an out. So I'll try to run this again. It must print hello world and it must print 3 plus 4, but not uh, these two lines. See, it has outputted hello world and it has outputted the number 7. Okay, so I think it's time. So we will try to continue our class uh, uh, in the next lecture. In the next lecture, we will be dealing with a few other concepts like the development life cycle of a program, and I will teach you what a pseudocode is, what a flowchart is and what an algorithm is, because you will have to uh, frame these these concepts before uh, writing logic or writing code for performing various operations. But since we have started, um, you can try out printing various mathematical operations, and you can try exploring idle, and let me know if you are facing any difficulty with using idle, and whatever I have uh, done today on idle, you can practice out at your end and see
Can you
how.
also give us this presentation link?
Yes, yes, I'll share it.
Okay, sir.
Fine. Let's call it a day, and
Thank you.
I'll let
Thank
you
you for your
know.
time, sir.
Yep, I'll let you know when our next class is scheduled at, and until that time, you can refer the links that I shared, and you just try to read the presentation once more. You and just try to recollect what are the points that we have discussed. You will be able to understand it much better. Okay, thank you.
Thank you, Sumant. Thank you, guys.